Your home is built with a bunch of material: wood, brick, metal, plastic, fibers, and glass. Our home, Earth, was also built out of material from the inner solar nebula, which is a cloud of interstellar gas and dust that condensed to form the entire solar system, including the sun and planets. Your home is also built in stages. This foundation has to be put in first, then the frame is put up, then the plumbing goes in, and so forth. In the same fashion, the inner planets, the 4 terrestrial planets, as well as our moon, developed in 4 important stages. This lesson will explain what they are, and it will use Earth as its primary example. The first stage of planetary development is called differentiation, the settling of dense material, like iron-rich minerals, into the center of a planet, and the rising of less dense material, such as the silicon-rich minerals, to the surface. Differentiation can be demonstrated at home by plopping some dirt into a cup of water. The rocks in the dirt, the dense stuff, will sink to the bottom right away. The less dense stuff will float near the top. Thus, our Earth has a dense core and a mantle and crust that is less dense than the core. The Earth underwent differentiation, like the animation of the moon on your screen, when its interior melted thanks to radioactive decay and energy generated by infalling matter. This melting allowed the Earth's material to sink or swim, depending on density, like the dirt in the cup of water. The second stage of planetary development is known as cratering, the bombardment of the early Earth by celestial objects like asteroids. In the early solar system, there were plenty of rocky bodies floating about that cratered the heck out of the terrestrial planets and the moon. Once the solar system cleared itself of these objects, the rate of impact obviously decreased. As I'm sure you can understand, cratering could not have occurred until Earth formed a solid surface after differentiation. Otherwise, the rocky debris would have just melted along with the rest of the Earth's molten makeup. The third stage of planetary development is known as flooding. There's nothing too difficult about this one, but there's one small catch. The flooding refers to 2 things. The less obvious one is the flooding of the deep impact basins on Earth with molten rock rising from the Earth's interior. Basically, lava seeped out of the interior through cracks in the crust and filled in the deep areas large impacts had previously formed. The more obvious one is the flooding of these basins by water thereafter, as rain fell from the sky to form oceans. The last stage of our planetary evolution is the stage we're currently in, called slow surface evolution, the ever-present changing of the Earth's surface by natural forces. What are these forces? They include plate tectonics, which create mountains, move continents around, and rip the Earth apart; erosion, as water carves, shapes, and wears away rock; and erosion as wind resurfaces the planet's features, like its mountain ranges. The solar nebula is a cloud of interstellar gas and dust that condensed to form the entire solar system, including the sun and planets. The planets themselves underwent 4 stages of evolution. The first stage of planetary development is called differentiation, the settling of dense material, like iron-rich minerals, into the center of a planet and the rising of less dense material, such as silicon-rich minerals, to the surface of one. The second stage of planetary development is known as cratering, the bombardment of the early Earth by celestial objects. The third stage of planetary development is known as flooding, where the Earth's impact basins were first flooded by lava and then later by water. And the last stage of our planetary evolution is called slow surface evolution, the ever-present changing of the Earth's surface by natural forces.